Hey, Carl here to say that Music to Code By is now an app called Music to Flow By. Now you can listen to the tracks on your phone with offline capability. The first 3 tracks are free, and the entire catalog is available by subscription with a new track arriving every month. Just go to musictoflowby.com for all the links. Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And we're still connect in New York City at Spring Studios down in Tribeca. Mm-hmm. And Joseph Sirosh is here. We're going to be talking to him in just a few minutes. But first, we have this little matter of a very geeky Better Know framework today.
All right, dude, what do you got?
You will like this, my friend, because this involves old hardware. This guy's got a device called a Flopotron.
I love it.
So using floppy drives, disk drives, and other old devices that make noise, he programs them to play music.
That's
like
awesome.
He programs them with the inherent noise they make.
I think he's got a dot matrix printer in there as well.
Yeah, it sounded like it, but he just says 64 floppy drives, 8 hard disks, and 2 scanners. And we'll put the link up there. It's 1497.pwop.me, or of course you can just Google or Bing Flopotron, Floppotron. He put one out for Halloween, Ghostbusters. Ghostbusters theme. And it sounds like bad arcade music.
Yeah,
right?
it's basically like 8-bit, old video game music.
But it's just these devices making noise.
Yeah.
It's so strange.
That is funny.
Well, anyway, that's what I have.
That's really cool, dude.
Who's talking to us today?
This comment comes from pseudonym Faulty. I'll presume that's not his actual name. Where it says, Carl's comment on detecting if he's chatting with a bot or a human reminds me of this RS Key app that by executing a set of calculations will result in indicating which chipset is being used in a scientific calculator, some even differentiating a clone. Maybe we can build a similar database of bot detectors that could lead to maybe an anti-bot war like AdBlock versus anti-AdBlock. So you could actually, when you get a bot, it just flags it as a bot as opposed to an actual human chatter.
Yeah.
I wonder if in the future the bot might open up a new vulnerability, maybe a backdoor with secret phrases to activate some hidden code or some way to trigger a buffer overflow just by chatting. Bot exploits. Botsploits.
Botsploits.
It is kind of an arms race, though, as these technologies advance to see there's a competitive advantage there with, cost-effective, immediate tech support. When do you escalate to a human if necessary? Like,
have you ever asked a bot, are you a bot? And of course they say no.
No.
Right? But
they always say no.
Yeah,
it's like,
but I feel like there's got to be some test, and it's not necessarily esoteric. Like, in Star Trek, Data couldn't use a contraction. You would never say can't. You would also say cannot.
Well, this is from the conversation we had with Galena, right? Which was exactly that. It's like, how are we not going to be able to tell when it's a bot's a bot? There's a whole other piece of software to be written there.
Yeah. You are much too happy to be a human.
Have you seen what you do for a living? So, Faulty, thank you so much for your comment. A .NET Rocks mug is on its way to you. And if you'd like a .NET Rocks mug, write a comment on the website at .NETRocks.com or via any of our social media, because we publish every show to Facebook and Google+. And if you comment there and we read it on the show, we'll send you a mug.
And definitely follow us on Twitter. I'm at Carl Franklin. He is at Rich Campbell. Send us a tweet. We run them through the Flopotron.
We set your tweets to music of sorts.
I can imagine you took all those tweets and you just turned them into a stream of bits and then just put them through an audio feed.
It would sound like a modem running, I think.
Sound like probably. All right. Well, let's bring our esteemed guests on today. Joseph Sirosh is a corporate vice president in the Artificial Intelligence and Research Group at Microsoft. He currently leads Microsoft's AI platform strategy and products such as Azure Machine Learning, Azure Cognitive Services, Azure Search, and Bot Framework. And prior to this role, he was the CVP for Microsoft's data platform. Welcome, Joseph.
Yeah, thank you, Carl. It's a pleasure to be here.
Pleasure to have you, sir. So what did you think of the Flopatron? Isn't that crazy?
Oh, yeah. I actually want to hear that Peter Frampton thing.
Oh, yeah, the talk box.
On top of that, that would be fun.
Do you feel like I feel?
No,
Yeah, I do exactly.
Yeah.
Do you feel like
My wife and I were, because I'm a musician, I'm a guitar player, and I was hugely inspired by Peter Frampton. So this is kind of funny. I was just saying to my wife yesterday, we were talking about, she says, I wash your underwear, give me some respect. And I said, okay, I've played the solo to Peter Frampton's Do You Feel Like We Do with a talk box, note for note, in front of 30,000 people. Top that. That's funny.
Yeah, it's interesting.
I love geeking out on this old stuff, and we've been geeking out on AI a little bit as well, and a lot of stuff going on here at Connect.
Yeah, lots of stuff. Platforms, I don't know if people had a chance to see, but we took the JFK files data and we organized and analyzed it with AI and created this awesome demo, and it just connects up all the different pieces of information.
So you've solved the conspiracy theory of JFK's assassination.
We did find something very interesting. We found SQL Server in there, in JFK files. And I'm thinking, hey, okay, SQL Server didn't kill JFK, but here's what happened. It was Congress had mandated that all this information be organized and assembled in a secure facility. Mm-hmm. And in 97, the platform they selected included SQL Server and Lotus Notes, and they have a whole architecture of how the secure classified information facility should be built with all of that. And that was in the whole treasure trove of documents that were released.
Was all
pretty funny.
Was some SQL Server, old SQL Server stuff.
Hang on, I'm getting a phone call. It's Oliver Stone. He wants to talk to you, Joseph.
Wasn't SQL Server on the grassy knoll, but it was SQL Server in a basement in Washington, D.C.
Well, it's amazing stuff that you guys are doing in AI, and maybe you can fill us in on some more of the things that you showed here at Connect today.
Yeah, happy to, Carl. So, look, we're building the platform of the future for AI, and it leverages all the power of the cloud. So, the explosion in AI is driven by a couple of things. Driven by the digitization of the world, so enormous amounts of data.
Social media. Everybody's pictures online.
Yeah, and every type of behavior is actually coming online, right? Yeah. For example, I have actually a fun story about connected cows in Japan, where Fujitsu has actually put pedometers on the legs of cows in dairy farms.
Cow measurements.
Well, yeah. Do cows need to take 10,000 steps a day? It turns out it's a very interesting application. Like, look, the one control that farmer has to maximize milk output is to really ensure that cows never miss a cycle of pregnancy.
Sure. If they don't have a calf, they don't get milk.
Yeah, that 1 month or so, you have no milk, right? Well, so when you have hundreds of thousands of cows in a dairy farm, how are you going to spot when the cow goes into heat?
Right.
Well, farmers in the past, they've done it by visual observation.
Right.
But when you have, so what happens actually today is you do miss pregnancy cycles all the time.
Mm-hmm.
Yeah.
Well, so Fujitsu discovered one really cool thing. If you counted the number of steps a cow takes and look at the ratio of the number of steps a cow is taking an hour versus the same hour the previous day, when that spikes up, the cow's actually going into heat.
Right.
Wow.
Looking for a bull.
So they have a heifer Fitbit.
Right. And then, so the optimum time then for artificial insemination turns out to be 16 hours from that.
Oh, I see.
Wow.
That's when AI meets AI, artificial insemination.
Somehow, I don't think we'll see that on the Flopatron.
That's right. But, the thing is, that's when you get maximum consumption.
Sure.
Yeah.
And Fujitsu discovered some amazing things when they looked at insemination time period. If you perform the AI, artificial insemination, the first 4 hours, you were likely to get a female calf.
Interesting.
And in the second 4 hours, you're more likely to get a male calf. Probabilistically, right?
Right.
Yeah.
Well, and it sort of speaks to have a family dairy farm, right, down in New Zealand, for better or worse. Not that I'm by any stretch of imagination farmer. I just have a certain amount of data. Depending on the kind of farm you're running, sometimes you do want to breed your new milk cows, and so you'd rather have females because they're going to give milk where the males are not.
What kind of time warp show did I just step into here? We were just talking to Brian Harry about cows because he's on a farm. And
keep having farming references.
There's a theme here. We got to go to New York to talk about cows.
Apparently.
Yeah. And so the thing that's awesome about it is a new type of behavior has been digitized. Mm-hmm. And then they have a service in the cloud. It's called Gyuho. Okay, CowStop. And the service then gets the data, scores it, detects the probability of the animal going in heat, alerts a farmer on a mobile phone. You got a closed loop.
Nice.
So sort of that's an amazing journey, right? So this is what's happening. So when you have data coming in huge volumes by digitization of everything, every kind of behavior from machines, from everything, then you bring that to the cloud. You apply enormous compute power. Then you put AI algorithms to work on the data. Then you're able to generate insights that are massive. And that allows you to do so many different things. You're able to do understanding of vast amounts of data. Could be JFK files or all your oil contracts. It then allows you to go also separately build systems that actually classify the information and help make business process efficient. For example, Jabil is one of our partners. They've got this automated optical inspection system for printed circuit boards. So you discover if a printed circuit board has a defect or not, right? I mean, a component is missing or something. The thing is, the system today is very manual. It flags some images, lots of errors in the images that are flagged. Lots of good ones get flagged incorrectly.
Right. False positives.
False positives. So they worked with us to build an automated optical inspection system using deep neural networks.
Okay.
So it then correctly classifies the printed circuit board as a good one or a bad one. And in this case, with 98% accuracy. So you can completely automate that quality inspection process. And this whole thing goes much faster.
I think there's a missing piece here, which is end users need to trust the output. And, I can only see the end users in my limited realm of life, right? Yeah. I see people that use smartphones and I see people that use computers, and sometimes, they're wildly off in what they interpret as reality. And so do you find that there's pushback among end users when you implement a system that has something like AI, sending you a message, an alert, hey, there's something going on here? The person has to trust that that's actually good information.
So let me answer it this way. Look, AI and machine learning is incredibly scientific. You're actually building scientific statistical models. You know their performance on the data it's trained on. You can put it in the field and evaluate its performance as the data is flowing through. You can see how accurate it is in very mathematical, quantitative fashion. Its error rate. So like, for example, speech recognition. We actually know its error rate. It gets quantified. So the thing that is great about today's machine learning versus rule-based systems of the past is that it's truly statistically scientific. Okay.
We saw this in the demos today, that they were showing the percentage accuracy and then they were showing the percentage result on a given test.
Right. And you can improve, but then again, every time it improves, you can actually even shadow test it and make sure it has actually improved. It's a quantitative, right? See, the thing that a lot of people probably don't fully grok is AI today is actually based upon scientific statistical learning.
That's been around for a long time.
Right. And it's just become so prominent because there's so much diverse data available. So when you didn't have all of this data, it's only a few, people working with, say, fraud detection in credit card world, which is my first job, by the way. By the way, that's an area where you can actually show you how much money you actually save by stopping fraud and how fast you stop it. And it's real. And
measurable ROIs.
Very measurable ROI. And it's really when it gets into these conversational systems that sometimes people are, wondering, hey, how well does that perform? But in the back end, you can quantify all of these things.
I'm thinking of the two scenarios you described earlier. So we have the cow scenario where you sort of discovered this relationship between being in heat and movement, which seems much more like an unsupervised. You had a whole bunch of data and you ran it through a data mining algorithm that found a correlation.
Well, actually, in that particular case, dairy science researchers had actually discovered it. Okay. They actually had published a paper about it. Fujitsu then went ahead and implemented it.
And made it into a product. But that to me doesn't seem like a deep learning solution so much.
That one was actually a pretty simple scenario.
Sure.
But in many of the deep learning situations as well, deep learning is really actually improving performance over more traditional statistical models.
Sure. Right.
Pretty much everywhere where there is a deep learning model, you could put a traditional statistical system. You just won't get very good performance out of it.
Well, and it seemed like that was the jump that happened with voice control systems, that we had this sort of traditional trained model that hit a limit and it only got so good.
Yeah.
And then there was a pause.
Right.
And then suddenly a significant improvement happened.
Exactly.
And it was a complete change in model.
Complete change.
You had to do the training, right? Whereas, you use something like Bing Speech, where you guys continually improve the model.
Correct. And so this is because of the representational capacity of the deep learning network. So these deep learning models are so big and they're able to go into the tail of the distribution,
right,
so to speak. Learn, things and learn and hold all of the information. That's really where the deep learning model just completely changed. So when you brought all of this capacity and then a few algorithmic innovations allowed you to train these extremely large models, then you just had incredible representational power that you didn't have with simpler models.
We saw a demonstration today, I think it was Seth doing it, where it was the disconnected vision. They took a bunch of pictures of fruit. They trained the model in the cloud. They ran it against the cloud. And then they deployed a version onto a phone.
Correct.
Turned the phone into airplane mode and it still worked.
Correct.
And I watched very closely. So I'm like, I love everything about what you're doing here. Is it really going to fit into a phone?
Yeah.
And I think the download was 3 megabytes. Like it was pretty small. So what are they downloading? Like how does this?
It's a compressed model.
Okay.
Yeah. It's a model that is actually very simple to execute on the phone. I showed a similar one. In this case, we were showing skin cancer detection.
Interesting.
Okay. So there's a public data set on skin cancer images, good ones, good skin cancer examples. And you can build a deep learning model to classify it.
Right.
Then I can go put it on a phone and, I can have just show the video camera or video over your skin and it will show risk at the frame rate.
Right.
So, these models can be relatively small.
So the learning is large.
Learning is large. You want a lot of data to learn lots of different things, right? And go into the tail, so to speak. There, by definition of tail, there are very few examples.
Right.
So you got to get large amounts of data to get all those examples. You learn a robust model, then you go build it into the phone.
Interesting.
And so the thing about Microsoft now is with the Azure AI platform and Xamarin, which allows you to build these great mobile apps cross-platform, you can empower every mobile developer with the power of AI.
Easy to add in.
Easy to add
Simple
in.
skill
Simple to add in,
Yeah.
I remember neural nets from back in the 80s.
Yep.
And
my first class in neural networks was in spring of 91.
oh my goodness.
Yeah. That was sort of about the peak too. After that, it went into this winter.
And into another winter. And there's been many winters, right? There's like a winter. Originally, they started coining the term, the Minsky and those guys in the 50s.
Yeah.
The first winter's in the 60s when the military figures out they're not going to solve everything in a month. And then there's another one in the 80s and another one in the 90s. But it's always, I guess, the hardware improves. So you go back and experiment with the models again. And then you hit a limit of some kind.
Yeah.
So what's different? I mean, neural network to me was this idea of just sort of weighted values in a tier of nodes. What's different today that makes that so much better than it was in the 90s?
Yeah. 2 or 3 things. First of all, the deep learning innovation really changed the representational capacity. So when that innovation happened, lots of types of neural networks that were conceived in the late 80s, early 90s, like recurrent networks, which didn't work all that well at that time, now started working much, much better, which are the capacity. So, see, there were lots of concepts invented at that time, like recurrent networks, reinforcement learning, and associative networks, and so on. These things all worked only sort of partially, so people sort of gave up on it. Now, when it became deep, these things started working really magic.
So what made it deep?
So, deep neural networks, previously most neural networks were 3 layers.
Right.
A hidden layer and then the classifier layer.
Right.
People actually mathematically showed that these 3-layered neurons had all the function approximation capability that you needed.
The return for a 4th layer or 5th layer was so low, there was no point.
It didn't seem like that. But then in about 10 years ago, some Jeff Hinton and some of his students showed that when you actually made the network like 10 layers, and then you came up with some smart ways to train them. Because when you get these 10 layers, it was actually really hard with the old simple backpropagation algorithm to train it. So they had to come up with some heuristics, some clever ideas. And since then, they have evolved a lot. When those clever ideas were applied, these things could just do dramatically better on computer vision tasks is where they showed it first. So that's then carried on. So right now, the best language translation is a neural translator, not a traditional machine translator.
Wow.
The best speech recognition is all deep neural network based.
Wow.
Best vision is all deep neural network based, and so on and so forth.
And guys, hold that thought while we just take a minute to hear a word from our sponsor.
Hey, Rockheads, this is Carl. Have you tried JetBrains Rider? It's a new cross-platform .NET IDE that's light yet powerful and comes from the makers of ReSharper, IntelliJ, IDEA, and WebStorm. You can write .NET code on Windows, Mac, or Linux. Rider has you covered. Rider helps you develop ASP.NET, .NET Core, .NET Framework, Xamarin, and Unity applications. Most languages used in .NET development are supported, from C#, VB.NET, F#, and XAML to ASP.NET Razor syntax, JavaScript, TypeScript, and all that other front-end stuff. It comes with navigation, thousands of code inspections, refactorings, unit testing, debugging, rich coding assistance, and more advanced IDE features powered by proven technology from ReSharper and WebStorm. Download Rider now and take it for a 30-day trial at rider.dotnetrocks.com. That's rider.dotnetrocks.com.
And we're back. We're at Connect in New York. Carl and Richard here talking to Joseph Sirosh, enjoying a little AI conversation with someone who's clearly worked in the space for a long time, and fun to go a bit down memory lane in that. There has been in the news lately this conversation about creating critical systems dependent on deep neural networks, these 10-layer deep, and not being able to prove mathematically or prove simply why it got a correct outcome or an incorrect outcome. It's always going to be the incorrect outcome where they're going to go, why did it get that one wrong? And it's not like it's a simple algorithm that said, oh, we had a bug in the algorithm. How do you measure a neural network's accuracy?
Yeah, that's a great question. So let me actually go back a little bit into another field. Most medicines, the way they work in the human body, most people don't know.
It's simply empirically measured. You're right.
Measured, okay.
Right.
So, but we have rigorous methods for it, right? We have randomized clinical trials.
Yep.
And you do rigorous statistical studies of controlled, in controlled ways.
Double-blind tests.
Yeah. And then you validate it safe. You will first do it in an animal model, then in a human. You validate it, and then you deploy the medicine out. And you track.
Right.
Well, AI is going to be similar.
Sure.
Okay. When you're deploying AI in mission critical applications that are super important, you're going to first test it in very rigorous ways. And you're also, while even it's operating, you're going to constantly monitor its performance.
Right.
You're going to, even in production, you're going to keep live testing it. Right. That's how all complex systems are managed.
And building up that test suite is going to give you an error probability. You're going to have a level of certainty around that based on the test sets you got. And as you build more data, have an even better set.
Correct. And so then what you have to have is when AI is taking mission critical decisions, if there is statistical error, which is going to be there in every system.
Sure.
Software has bugs too, by the way. Well, you have a way to reverse it, right? You have to fix the error.
Yeah.
Compensate for whatever it did bad and move on. That's how all of society works anyway.
Sure.
So no different.
Yeah, and I appreciate your medicine example, especially where it's like we find out there's a certain group of people where this medicine's inappropriate, but didn't get caught in the initial sample set, so we didn't know. Right. And now we know, we make an alteration, and that's probably going to be the same thing. Yeah. Because the other more algorithmic, prune tree approaches, they're much more measurable. They're very direct. Once you find a model that makes sense, it's like you can see this math makes sense.
Only the simplest ones.
I guess that's true.
Only the simplest ones.
Right.
And by the way, vast majority of software that we use in the world and runs our economy is so sophisticated, nobody can prove it either.
Sure.
That's right. It doesn't exist except in our heads, really. And it's software.
It's pressing against the edges of comprehension for us, I think.
It's fair to say, at no other time in the history of the world have so many people known so little about so much.
Can't argue with that.
Some of us know less than others.
That's right.
It's when you don't know that's the problem.
Yes. Don't know enough to know you don't know.
Oh, right. I don't know if you know this, but Richard actually worked with neural networks in some stock picking stuff back in the 80s.
Back in the day, we did some horse racing too.
Horse racing, stock picking.
We played
and
with that.
I even had a little programmable neural network that it was probably 1990. 1989.
It was a hip time for that.
It was a hip time. And I never did any stock picking with it because I'm like, all right, you're giving me a database of stocks, you're giving me a tool. I press go and I pick the stock. It's the kind of,
Yeah. So deep neural networks are now being applied in the financial markets widely. People are, whenever there is a new algorithmic technique, people want to go try it out.
So why would anybody invest in the stock market when you're competing with these machines that just do it like in microseconds?
Well, I think long-term investing is the key.
Yeah. Because you have different set of perceptions. When we did the horse racing thing, there's certain kinds of races that the model did really well on. But I remember watching old horse guys who literally watched the horses go by and then go, it's that one. And they got like a third of the races right.
Yeah.
And we were getting about a third of the races right. They were just different thirds.
They didn't have the heifer Fitbit.
There you go. Different measurements. But it is, I mean, nobody's going to deliver 100%. There's different methods for each thing, and they are each going to get wins in different areas. And it's to me, that's fine. I find that fascinating. It's tough to know one way or the other.
So would you call that a heifer data set based on large models? Heifers are pretty large.
It's going to be a lot of cow jokes today, huh? So that's the kind of day we're having here.
Oh, it started with Brian Harry, so.
That's true. Yeah. What is the fixation with the GPU? Why are GPUs important to the modern AI movement?
Great question, right? It's really because of the vast crunching power that you need to learn these deep neural networks. And if you're doing it on a CPU, it takes weeks, months. It's just not cost effective either.
The CPU arguably is too complicated a computing unit for the individual task.
Not enough computing unit. See, the deep neural networks are actually simple computations. It's add, multiply.
Right, but lots of them.
Right.
Lots of them. Vast amounts of them. And so GPUs were just built for that on images.
Yeah.
Right.
So people just repurposed it to apply to deep neural networks, especially when it came to computer vision, because it was naturally 2D images. GPUs were already good at processing 2D images.
Sure. The thing about GPUs is the limited instruction set. Is that what makes them so fast?
The large number of cores. Yeah, it's a small number of operations that it really does. Right.
Yeah.
And it's
but a huge number of cores.
Large number of cores.
Yeah.
And you can repeatedly do it over, a repeated data set. And so that just made it a lot easier. But now, new types of approaches are coming, like FPGAs.
Yeah.
Okay, FPGAs are great.
That's a floating point.
No, actually it is a field programmable
right.
array, right? So it's basically configurable computing. You actually arrange the logic gates, etc., to do the computation you want. The good thing about it is it allows you to go after irregular computation. See, image computation is extremely structured, regular, 2D arrays, right? When it's text data or sequence data, well, then it's not that great. GPUs are actually not as great as it's for images.
Yeah.
So then things like FPGAs become much better.
Okay.
And then people are even building ASICs for
sort of dedicated hardware.
Dedicated hardware, application-specific integrated circuits. Okay. Lots of innovation there. Lots of innovation to come.
I think it's interesting that the amount of compute you need to do some of these more advanced models, especially when you're building the model. Once the model's built, you don't need a lot of it. So suddenly utility computing, the whole cloud approach, makes so much more sense because you only use it when you need it for building the model and then you give it back.
Yeah. And I think this is going to be the wave of the future in that. Vast amount of AI will be built in the cloud. Okay. People will just put data in the cloud. Right. So you need to put huge amount of data. Putting on a single server, not really viable. It's expensive. Then also getting enough GPUs.
Yeah.
Painful if you're trying to outfit your data center with GPUs now. And by the time you instrument all of that, then the GPU version changed. You might as well just elastically provision it in the cloud.
Yeah, right.
So you come up to the cloud, elastically provision your GPUs, run it on all the data you have, develop these models, and then you go deploy it wherever you want. Yep. You can deploy it in a database like SQL Server or mobile phones or the edge.
Yeah. Hey, Richard.
Yeah, buddy.
Guess what time it is now?
Must be that happy time again.
Yep. It's time for a real obvious joke that I missed, and I need to apologize, but I'm going to tell it right now.
Okay.
So 3 statisticians go deer hunting. They see a deer. First statistician fires at the deer, misses 10 feet to the left. Second one fires at the deer, misses by 10 feet to the right. The third one jumps up and down and says, I hit it!
And a bullseye.
Right on! But wait a minute, that deer's still alive. How did I do that?
Yes.
And that same statistician crossed the river whose average depth was 4 feet.
Right.
That's awesome. That's actually time to give away a DevExpress D-Experience subscription to one lucky member of the .NET Rocks fan club. Become a UI superhero with DevExpress UI controls and libraries and deliver elegant .NET solutions that address customer needs today and leverage your existing knowledge to build next-generation touch-enabled solutions for tomorrow. Whether it's an Office-inspired application or a data-centric analytics dashboard, DevExpress Universal ships with everything you'll need to build your best, without limits or compromise. And check out their DevExtreme React Grid, built from the ground up to fully support all the cool features that come with React, like the virtual DOM and state controllers like Redux. It supports master detail, sorting, grouping, paging, and editing. And you can check it out and test it for free on GitHub. But learn more and download your free 30-day trial of DevExpress Universal at devexpress.com/superhero.
All right, buddy. Who's our winner?
Today's winner is Bill Mason.
Congratulations, Bill.
Yeah.
Golf clap for you, sir.
And Bill won the D-Experience subscription, a big pile of awesome from our friends at DevExpress, just for being a member of the .NET Rocks fan club. And if you don't know what that is, go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the fan club. We have thousands of members all over the world, and every show we like to give away stuff from our sponsors. And every December, coming up, not this show, but coming right up
Real
here, real soon, we are going to be giving away a $5,000 technology shopping spree to one lucky member of the fan club, but you got to sign up to win. And we also like to ask our guest, Joseph, if you had $5,000 to spend on technology today, and it can't be Azure Compute Hours credits, what would you buy? I guess it could be Azure Compute credits.
Kind of an easy one.
I don't know. I'll probably buy on some add-on to my Tesla.
What don't you have on your Tesla?
Actually, I bought an older version, so I don't have any.
You don't have all the autopilot stuff?
you don't have
autopilot. I don't have the sensors,
You
and
don't have the
I
speech
bumped my,
recognition?
the car a few times.
You just
now.
have an electric car?
I know,
Dude, you're missing out.
It's just like a hairdryer on wheels.
Don't they pay
all I
VPs
have.
enough? You should go get a shiny new one.
How about the speech recognition interface so you could drive it by saying 10 degrees to the left, 13 degrees to the right? That's right.
What could go wrong?
Because
I
it's
know.
scientifically and statistically proven to
Just not tested.
Well, and they now have two autopilot levels too, right? Like,
Yeah.
The only feature I wouldn't buy in my Tesla is the P option, the ludicrous mode, because it's like $25,000 to shave a half a second up the 0 to 60 time.
You got to tell us what this is. I know you've said it before, but tell everybody what that is.
So
ludicrous mode.
The ludicrous mode, literally, the top of the line Tesla, the most expensive model with everything on it. This is the S.
Yeah.
Has this ludicrous acceleration option, which gets it down to a 0 to 60 in the race car range, like two and a half seconds. It's crazy. And the normal one is 3. But in exchange for that, that's a big pile of money and a shortened battery distance.
And it comes with a free upgrade to your health insurance policy because you may black out with that many G's.
It's interesting how deeply wired in our brain the sort of gear shifting.
Yeah.
What? Teslas don't do that.
No.
They just keep going faster, and their acceleration curve is flat.
Right.
So they accelerate hard, and they stay accelerating hard, you know, until you run out of battery or hit a wall or wind force finally pins you down. It's quite creepy.
Yeah, I've experienced it.
So, yeah, just saying.
You should buy one.
But $5,000, I think I'll get you a charger. Expensive toys, those Teslas, no question. Yeah, I'm of a mind now that my lease comes up on my current car next year, and I'm looking at automated driving and mobility as a service and thinking, whatever car I buy next, probably the last car I buy. That I'm going to have that car for 3 or 4 years, and that puts us in the 2020, 2021 time range, and we're going to start seeing just fully automated vehicles. And you're just going to call up for the vehicle you want at the time you want it. It's going to take you. And why would you own a car at that point? It makes no sense.
Or ride sharing becomes so good that you just get it right.
It just makes, you want. Why would you do anything else?
Yeah.
So
and something even simpler.
Yeah. I kind of want to, so I figure I get the Tesla as sort of the last thing with all the autopilot. And that's the car I could probably drive for the longest because it will have the automated mode anyway. And then that's probably it. I just don't think there's going to be more. I blame the AI guys. It's all your fault. You did this.
Speaking of AI, let's get back into it. What is the coolest, you think, cognitive service Microsoft offers? Because there's a lot of them and they keep growing.
I think language understanding service now
Lewis.
that we have, Lewis, it's actually becoming so powerful for conversational bots. Just understanding text, being able to train, understand commands, intent. It's actually evolving so fast. And we now can use the translator along with it. So you can actually have bots that are developed once, but run in so many languages across the world. And so I think that is really cool when you couple translation, language understanding, create these bots with Azure Bot Service.
That's Star Trek stuff right there.
It's very powerful for interaction.
Yeah.
And I think that's really cool. And then even the other services like speech recognition, the error rate is dropped dramatically.
Right.
You saw the new Invoke speaker that we have. It's actually really effective at speech recognition. So I think, collectively we're making significant progress. And the thing to remember about cognitive services, it's not just the algorithm. It's sort of that expertise behind speech recognition, for example, or language understanding. It's all the data on which it was built.
Right. And continues to be trained on.
Continues to be trained on. And all the cloud power that went into building that model.
Right.
So what you're getting is not an algorithm, right? What you're getting is actually a finished service. Somebody with deep expertise collected all of this data, built this incredible model, tested it for accuracy, validated it, put in production, and then continues to improve. So that's a different thing about these cloud-hosted APIs.
Right. Yeah.
Well, and from a dev point of view, it's like, because I don't want to do any of that stuff. I just want a service.
You just want pre-built components. So the thing is, like, when people build buildings these days, you don't build it from brick and mortar. Right? Remember the Chinese who built like a hotel in 6 days and restaurant on the 7th day?
Sure.
I mean, so that was built out of prefabricated components.
Right.
So the idea is like prefabricated components are what makes building easier. Software and AI is going to be very similar.
Sure. You also have the ability to plug in your own data to the existing algorithm, don't you?
Exactly. And you can customize these, custom speech, train it with your accent, vocabulary, and language. And then when that also isn't enough, that's when you go to a deep neural network model built on Azure machine learning or something and add on and augment it and make it better. So what you're going to see, I have this vision, and I think it'll come real, which is imagine there'll be 1 million APIs in the cloud. Like you're okay with a million apps in your iPhone App Store, right?
Yeah, but, I don't think I actually am okay with that.
I know, but you wouldn't have. I mean, you're comfortable with it now. If somebody had told you, 10 years ago, even, that there would be 1 million apps on your damn phone, what would you have said? Unlikely. How will that happen?
Well, I think I got about 150, which is already too much. But I get your point. It's like eventually there's this diversity of everything you need up there.
Well, so you'll have APIs, right? APIs are more powerful than apps because they can be glued together by a developer to build apps. So I can easily envision a future when you have a central cloud, in which people can build and host vast numbers of APIs of all types. Well, those are available to you now for application building. And the software development task changes dramatically.
Sure does.
Because there are all of these highly powered APIs that somebody with expertise and knowledge and data developed and built, like the speech recognition APIs. And then my task as a developer
is chain things together. That's it.
Yeah, chain things together.
Stitch the inputs through the APIs to the output.
Yeah, you're not going to be like, the tailor making every single stitch with your needle. You're going to just connect up pre-built parts.
You're not weaving your own cloth anymore.
And what are you guys doing for discovery of those APIs? Because obviously, if we're going to have 1 million APIs, we got to be able to find the right one I need right now.
That's right. I think we need much better documentation and everything.
Documentation is awesome. Discovery a little bit different.
I mean, I think just like internet and search, we've got to invent new mechanisms to find what the right APIs to use are, how to test them. The testing part is important.
Right.
Figure out then which ones to use. It's all work in progress, but those are the
challenges.
Those are challenges that we'll keep making progress on.
Yeah, no question. Do you think about creating a sentient piece of software?
Not at all. I mean, I really feel we've overhyped this term artificial intelligence.
Sure.
Right? Yeah. This is all just scientific algorithms coming.
You do think we'll get to more of a generalized intelligence in the sense that ask it anything, give it a broader range of tasks, not as specialized as it's been?
Look, I think it's so far away. I mean, look, let me tell you something. We haven't even taught machines how to remember.
Right.
Like, what's memory?
Right.
Well, forget memory. How about locomotion? Show me a robot that can actually walk like a human being.
Yeah. Well, the Boston Robotics guys are getting better at it.
They're getting better at it, but these things are like still very hard problems.
And I'm not going straight to Terminator. I'm sure the first time we talk about something more AGI-like, a broadly conversational bot, it'll still be a bot on the internet.
You know what humans have that bots don't? Of course, now lots of things, but humans have the ability to forget.
Yeah.
As an even more important thing that I feel comfort in, humans have a survival instinct. We'll kill any AI that threatens us.
Yeah. Well, I also think this idea of will, right? Like, one would argue that the AGI fear is not that it comes up with its own ideas and goes and does things. That you ask it to do something and it does it to an extreme unacceptable in society.
Right.
That it's a little too good at its job, so to speak.
So what would they say on like Star Trek? Data's algorithm for appropriateness needs a little tweaking.
Yeah, it needs a little tweaking.
Yeah.
Long before we get anywhere near that tech, we're going to get ourselves in all kinds of trouble with the ASIs.
Yeah.
We think about the insanity that went on in Facebook and Twitter over the last U.S. election, and that was kids in Montenegro just trying to make money off of ads. What happens when you actually put some serious software to the task?
But they found that not only that, but the Facebook algorithms that were serving up ads, did you vote today, for somebody who is left-leaning were totally different from somebody who is right-leaning.
Sure.
And they actually figured this out. The only way to really know is to have multiple profiles and go, friend the right people for that profile, and then you'll see a difference.
Yeah, I mean, I think, people have constantly feared technology, and this is no different. And I really feel the other way. There is incredible amount of optimism to be had.
But technology can be abused.
Like everything in society.
Sure.
And so what you need is good government, good regulation.
Well, I wonder if the fact that all this stuff's going to run in the cloud means that the public cloud providers are going to have an opportunity to provide some governance.
Correct. And so the thing is, this is an important thing about cloud providers, which is all of them. Their business depends upon security. Their business depends upon trust. Their business depends upon complying with laws. There is a lot of incentive across the major cloud providers to provide very trusted, safe environments. Actually, that's a good thing.
Sounds like all of the big providers are collaborating, stuff like the partnership on AI.
Right? We abbreviate them as FATE. Fair, accountable, transparent, ethical AI. And I think AI should be always in the interest of humanity.
We totally agree. And we saw that at Build, with the demos that they did, the AI demos where you couldn't argue with the benefit that you were getting out of these things.
Right. I mean, just take even healthcare, for example. Right. There is so much potential for AI to improve human lives in healthcare. To predict chronic conditions. Like one of our partners, Epic Systems, they looked at electronic medical record data and showed they could predict hypertension up to 2 years in advance.
Yeah.
And they can look at common workflows in hospitals, simplify them so the doctors have more time for the difficult cases. Yeah. So it's just going to make it so much easier for us to provide better care for the 9 billion people on the planet.
I'd be satisfied with HI in healthcare, human intelligence.
Yeah.
But sometimes we don't see
and second,
that.
AI being scientific can help systematize lots of aspects of this, right?
Yeah.
Very powerful. And I think, another thing is machines that never fail, like predictive maintenance. You can predict when machines are likely to fail.
Right.
Sure.
So I think
safety too.
Applied in the right way, AI has the ability to transform human civilization in a very positive way. Make us healthier, make us happier, make our machines more reliable, create an incredible amount of opportunity for humans to go higher as opposed to, lower and, keep working in the ground.
It is a way forward, but it does present some ethical challenges. It does present some new efforts. I don't think that software people as a whole have needed to think this deeply about, what are you going to do with this stuff?
I think that's a big responsibility on our shoulders. I mean, primarily because, way back, Mark Andreessen, I think, said software is eating the world.
Yep.
Right.
So when software becomes the fundamental fabric of economy, I mean, it's already happening, right?
Yeah,
the vast amount of time you spend on the phone, it's just because it's software.
Yeah.
Well, the challenge here is we're the chefs. And so at some point, people might be annoyed with the food we're making.
Right.
So we got to think clearly about what it is we're cooking.
But I really appreciate what Microsoft is doing in that regard. It really seems, I mean, Satya, the grand leader of all of this stuff, it's his vision to make a better world.
Exactly. I mean, our mission is to empower us all. And we repeat it at every opportunity in the company. And really augmenting human abilities is what AI is about and what a lot of this software is about.
So, Joseph, what are you going to do when you go home? What's next for you?
I think a lot of planning. Yeah. There's lots of excitement around AI. And the question is, given the incredible wealth of opportunities we have to go after, what are the best ones to put forward? And
it's got to be a challenge to prioritize. There's just so many things to work on.
Prioritizing is hard.
Yeah.
Yeah. And right now, this explosion in AI is so broad. It's a confusing world even to us.
Yeah.
Sure. Yeah. Sort of got a tiger by the tail.
Well, and we're happy to go along for the ride with you.
Yeah,
guys.
it's an amazing journey, right? And so the thing about computing is these waves, the waves of the mobile, the cloud, AI, they come so quickly these days, right? Waves crashing up on each other. And it's actually exciting and a very creative time.
Yeah.
Absolutely.
Very, very creative time.
Joseph, thanks for being
Thank you
here
very
with us
much.
today.
Yeah.
It's a pleasure.
My pleasure to be here.
All right. And we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter banned by the FCC.